Section 5.4 will be a quick lesson just going over four-sided polygons. So let's start with what a polygon is. Polygons are plane figures, meaning anything that can be drawn into a singular plane. So such examples would be a triangle, a quadrilateral, or really any sort of multi-sided object. Doesn't have to be even, but the lines do have to be straight, even though this last one isn't necessarily perfectly straight. Non-polygons can be in the same plane, but again, you could have something where the lines aren't straight, they curve, or if they break apart and connect here and continue, or maybe they share the same line. So this right here could be an individual polygon, but the figure as a whole cannot be. So how do we name polygons? Well, in this case, this polygon can be named as figure ABD, DAB, as long as it connect all 3 points and it continues in one direction or the other. It doesn't matter which point you start with. What you cannot do in naming this figure is you cannot say something like BCDA or CDAB, etc. Because C is a point on the line and it needs to be non-collinear to name the actual polygon. A convex polygon is a polygon in which each interior angle has a measure less than 180 degrees. So you can think of many multi-sided figures for this. You can think of an octagon, triangle, quadrilateral, whatever you can think of. But again, each of these angles in here has to be less than 180. So an example of what wouldn't be a convex polygon would be a figure like this, because you'll see both here and here the measurement of the interior angle is obviously more than 180 degrees. For most of this book, we will be just working with convex polygons. Now, another definition you're probably familiar with is diagonal of a polygon, which is any segment that connects two non-consecutive vertices of the polygon. If you look at this hexagon right here, let's draw the diagonal. So here would be a diagonal from this vertice there and there. You'll notice that each of them will have 3 coming off of it, but this is not a diagonal, and this is because it is connected to the original vertices, so that doesn't count. So then you can go from this across here to here, and again here to here is not a diagonal, again, because it's connected right to it. And we can go here, but you'll notice it starts repeating. Once I go back, it shares that same line. This is a new one, and this is a new one. And then here, same sort of thing. The first 2 repeat, and then we go there. So you can see in this hexagon has 9 diagonals in total. We're just going to briefly go over quadrilaterals. We'll be spending a couple days in the lab really exploring each of the properties of each one and how they're classified, and again, kind of the special, unique properties of each one. The basic definition that we're going to be exploring the next couple lessons is a quadrilateral, which is any 4-sided polygon. It doesn't matter if it has congruencies, parallel lines, etc. It is simply just a four-sided polygon. The next one is a parallelogram, and as the name suggests, is parallelogram. It's a quadrilateral, so it has to be four-sided, in which both pairs of opposite sides are parallel. So if you look at this, and we're going to mark parallel lines with double arrows, those sides would be parallel as these sides will be parallel. Again, there's more properties to parallelograms, but we'll explore those in the labs as well. Rectangle is a parallelogram in which at least one angle is a right angle. Again, you probably are kind of thinking, well, I know a rectangle has four right angles. Well, in order for it to be a rectangle, you just need to define one of the angles to be right, because if you establish one right angle based on some of the theorems and properties we talked about, all four indeed will be right. So if you just establish one right angle, and if you establish a parallelogram, then it will be indeed a rectangle. The next one is a rhombus, and a rhombus is a parallelogram in least at one angle is a right angle. Nope, sorry, that was the rectangle. A rhombus is a parallelogram in which at least two consecutive sides are congruent. So again, what you need to do is you need to establish a parallelogram, so you need to somehow establish two pairs of opposite sides that are parallel. Then you establish two consecutive sides which are congruent. What you'll notice then is that all four sides will be congruent. But again, to state that's a rhombus, you just need two consecutive sides. Next, we have a kite, which is a quadrilateral in which two disjoint pairs of consecutive sides are congruent. And what this means is that you're going to have consecutive sides, meaning a side here and here, but the disjoint means that the disjoint comes right here between the two. So you'll have the pair congruencies over here, and then another pair over there. Next, we come to a square, which is a parallelogram. So again, you establish a parallelogram, and then you have to establish that it is a rectangle and a rhombus. So again, in order to be a rectangle, you need to establish one 90-degree angle, and in order to establish a rhombus, you need to establish one pair of consecutive congruent sides. Trapezoid, which is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases. And lastly, we come to an isosceles trapezoid, a trapezoid with non-parallel sides, where the non-parallel sides are congruent.